Question 19, we have spheres of mass 0.6 and 0.8. They're on a string 0.5 long. And let's straight away just get this distance in here. This x distance, that is going to be down to that point here. And then we'll be able to find what this height here is, taking it away from 0.5. So we've a and h, so the cos of 60 is equal to x over 0.5. So the cos of 60 is a half times a half is a quarter, so x is equal to 0.25. So this height is also 0.25, just to get up to 0.5. So we can get that straight away. That'll help us. It looks like kinetic energy and potential energy going on here. We're looking for the speed of the 0.6 just before the collision. So that's before anything kind of happens. So we have this system of potential energy and kinetic energy before, which will be equal to the potential energy and kinetic energy afterwards. Now, at the top, the speed of the kinetic energy, mv squared, is 0. It's released from rest, and afterwards the potential energy is going to have a height of 0 down here at the bottom. So that will be 0, 2. So we'll be able to just say the initial potential energy, this mgh, will be equal to the initial, or the speed, the kinetic energy, which will be a half mv squared, which will be the kinetic energy afterwards. So we have the mass 0.6 times g, we'll leave it as g, I think, 0.6 times g times h, 0.25. That's a quarter of 0.6, which is 0.15 g. That has to be equal to, well, they're all decimals here, 0.5 times m, 0.6, and a half of 0.6 is 0.3 times v squared, 0.3 v squared. So v squared is equal to 0.15 g over 0.3. Looks like 1 over 2. So v squared is equal to g over 2. So v is equal to the square root of g over 2 meters per second just before impact. So the velocity, I think I might decimalize it. 2.2. And it's 2.21359. I'm just going to take 2.2. I think I'll try to do it with the g over 2. It's a bit messy. So we've now got a before and after situation, and we're looking for the speed of each sphere just after the collision. So we have our 0.6 and our 0.8. We have the 0.6 is traveling at 2.2. The 0.8 is at rest. And we'll call the speeds after P and Q. So just using our equations, we're going to get P minus Q over 2.2 minus 0 is equal to minus E. Not told anything about E here. Well, we actually have to be, don't we? Here it is up here. Didn't read the question. Should read the question. Minus 1 over 11. So we're going to get 11P minus 11Q is equal to minus 2.2. Now 5 2.2s is 11. So I could divide by 2.2 to get, may help. So I get 5P minus 5Q is equal to minus 1. So my other equation, 0.6 by 2.2 plus 0.8 times 0, so I'll just write 0 is equal to 0.6p plus 0.8q. So 0.6 by 2.2 is 132, so 1.32 is equal to 0.6p plus 0.8q. Now none of them go up to 5, so what am I going to have to do here? Let me see. So if I multiply this one by 6.25, dividing 5 by 0.8 to figure out how we can cancel the q's, I'm going to get 8.25 is equal to 3.75p plus 5q. I'm bringing this one across. I'm going to get minus 1 is equal to 5p minus 5q. Adding these two lines, I'm going to get 7.25 is equal to 8.75p, giving me a value for p of 0.83. If I round it off, 0.83. Sorry, not 4. It's coming up at 828, so 83. And if p is equal to 0.83, 5 times 0.83 minus 5q equals minus 1. So 5q is equal to 5 times 0.83 plus 1. So I have to divide the whole thing by 5 to get q. And typing that into a calculator, I get q is equal to 1.03. And these are speeds, so meters per second, meters per second.